Today for resonance, that is for class 12. Here you see that you have learned that I max, that is equal to V max by Z. This is the impedance, and your Z is equal to root over R square plus XC minus XL the whole square. That is impedance by capacitance, and this is the impedance by inductance. So here we know that Xc is equal to 1 by omega c, and XL, that is equal to omega L. Now what happens when your Xc is equal to XL? When Xc becomes XL, then this cancels out, and Im will be is equal to Vm by R. That is the maximum current here. This means this is the maximum current. Maximum current. Yeah, this is the maximum current. So here we see that when Xc is equal to XL, then Im is maximum. So how Xc is equal to XL is possible? So 1 by omega c is equal to omega L. So 1 is equal to omega c LC. So 1 by LC is equal to omega square. So 1 by root over LC is equal to omega. So this is the frequency. Then that means there is some frequency where at that frequency your Xc will be equal to XL. That is the some frequency where your Xc will be equal to XL, and at that frequency your current will be maximum. Your current will be maximum. So that frequency LC, that frequency is called the resonant frequency. This is called the resonant frequency. This is called the resonant frequency. Means this is I am speaking about the else because I have uh, you all know that this is an LCR circuit. This is for an LCR circuit. This is for an LCR circuit. So you know about LCR circuit. So I have not explained anything about a LCR circuit because I want to give a stress on the resonance. So here LCR circuit, Im is equal to Vm maximum is equal to Vm by Z. Z is the impedance. So this impedance equal to R square plus Xc square minus XL the whole square. Now if your Xc is equal to XL, then the current will be maximum. That is, it becomes a purely resistive circuit. That means it becomes a purely resistive circuit. So your that will be your maximum current. So Xc is equal to XL. When this is possible? When this is possible? So we are going towards frequency. We are going towards frequency. That means omega square LC. So this is your frequency. So there is a frequency when your Xc will be equal to XL and you will get the maximum current. That means your graph will be here. This is Im graph and Im graph, and here this is frequency graph. So there is some omega naught resonant frequency where you will get the maximum current. When you are going to get the maximum current, there is a frequency. So by adjusting the frequency, we can get Xc is equal to XL, and we will get the maximum current because your this XL also depends on frequency, and your Xc also depends on frequency. So here comes the main theory, frequency. So this LCR circuit, it is utilized in radio receiver. How? My objective is here to explain how. So here you see one thing, that is the you can't vary inductance. You can't vary an inductor because it is a fixed coil of a given length. It is a fixed coil of a given length, so you can't vary this inductor. That means you can't vary the inductance. This will remain the same as in the circuit. Only we can change this capacitance. How? How we can change this capacitance? Because your capacitance, it depends on area. It depends on the area of the plate. So by changing the area of the plate, we can change this omega by changing the area of the plate. This is possible. This is possible. That is, we can change the area of a plate. This is possible. So by changing the area of the plate, we can change this frequency. We can change this frequency. That means the frequency of the circuit. This is the frequency of the circuit. That is LCR circuit. This is the frequency of the LCR circuit. So this LCR circuit, it has its own frequency. So uh, we can change the frequency by changing the capacitance of the capacitor, because we can change this frequency of the circuit by changing the capacitance, by changing the capacitance of the capacitor, by changing the capacitance of the capacitor. We can change this. We can change this. So this this is possible. So this theory has been utilized in the radio receivers. How this has been applied in the radio receivers? So here you see that in a radio receiver, it has an antenna, means the radio receiver. Here you see the radio receiver. Here we'll see the radio receiver. It has an antenna, which this antenna, it receives different frequencies from different broadcasting stations. Means this antenna, it can receive different frequencies from different broadcasting stations. Now it has an LCR circuit built inside, and this LCR circuit, it has, and this circuit had, we can, by adjusting the capacitance of the capacitor, by adjusting the capacitance of the capacitor, means this, your tuning, this tuning, it works on the, this tuning, it is a capacitor, and by adjusting the capacitance of the capacitor, how? By this capacitance, by changing the area of the capacitor, this you can tune it. That means tuning is, that means this receiver set, it has different resonant frequencies. It can change its frequencies. It has different resonant frequencies. This capacitor, it has different radio set. This circuit has different resonance frequencies. Now the frequency received by this antenna, the frequency, this antenna can receive different frequencies from the broadcasting station. So the frequency received by this antenna, it acts as a source for this. Here it is in U tuning, for this tuning circuit. It acts as a source. The frequency received from a broadcasting station, it acts as a source for this tuning circuit. This is the tuning circuit, and this tuning circuit, it has a different resonant frequencies. It has different resonant frequencies. The different resonant frequencies, different resonance frequencies, that different resonance frequency, it can change its frequency by changing the capacitance of the capacitors. Here this, which gives you the broadcasting station, here this is a capacitor, and this capacitor, you can change its capacitance by changing its area. So here what happens, that when your antenna is, it becomes the source of frequency for the tuning circuit. For the tuning circuit, that is, this is the tuning circuit. It acts, the frequency received from this from the broadcasting, it acts as source. Now, if by by changing the capacitance of the capacitors, that means by changing the capacitance of the capacitor of the tuning circuit, that means you are changing the, by changing the capacitance of the capacitor, by changing the capacitance of the capacitor of the tuning circuit, of the tuning circuit. That means we can change the capacitance of the capacitor of the tuning circuit. Now, the when the resonant frequency of the circuit, when your resonant frequency of the circuit, when the resonant frequency of the circuit is nearly equal to, is nearly equal to the frequency of the broadcasting station, frequency of the broadcasting station, when this resonant frequency of the circuit, means this circuit, it has different resonant frequency, which this can be done by changing the capacitance of the capacitor. When the resonant frequency of the circuit is nearly equal to the frequency of the broadcasting station, you can hear the sound, you can hear the sound clearly. You can hear the sound clearly. That means the all the things which are broadcasted by the broadcasting station, you can hear it clearly. So this is the main resonant frequency. Means at this resonant frequency of the circuit, your current will be maximum. Your current will be maximum for the the current, that is the, at this case, in this case, your current I max in the circuit, I max, this is the I max, your current will be maximum, your current will be maximum, maximum in the circuit, in the circuit for the frequency, of the broadcasting station, your frequency will be, the current will be maximum in the circuit for the frequency of the broadcasting, when your resonant frequency of the circuit is equal to the frequency of the broadcasting station. When it becomes equal, then you can hear the sound clearly. That means you can hear the sound clearly. Let us see here. Because here I am adjusting the capacitance of the capacitor, and here you see, that means I have adjusted the resonant frequency of the circuit by changing the capacitance of this circuit, and this frequency, when this is nearly equal to the frequency received from the broadcasting station, you can hear the sound. So here you see, sorry, you can hear this sound. So this is how your radio set works. This is how your radio set works. That means at this uh, when the at this frequency, means at this frequency of this broadcasting station, your current in the circuit is maximum. Your current in the circuit is maximum. So this is how LCR circuit works in a radio receiver. This is how it works in a radio receiver. So thank you. This is all I want to tell you about the resonance. Now my next topic is on electric dipole. Electric dipole. Here you see that I have again repeating it because to make it clear to the students that when you place a dipole in an external electric field, when you place a dipole in an external electric field, so when you place the dipole in an external electric field, we know that the direction of the direction is from negative to positive. So when we place a dipole, that is dipole, electric dipole, so it has a electric dipole moment. So this external electric field, because the two forces, the net force is zero, no doubt the net force is zero. But the two forces here, the two forces acting on this Q or plus Q and minus Q, they are separated by a distance. Because the two forces acting on plus Q and minus Q, they are separated by a distance, which result into a torque. That results into a torque. Remember that the net force is zero. We have placed this electric dipole, electric dipole in an external electric field. There are two forces here because because of the electric field, we know that F is equal to QE. We know this. So here there are two forces acting here, but the net force is zero. The net force is zero. But since the forces are acting at a distance, so it creates a torque, and that torque is always perpendicular. That torque is always perpendicular to this plane, the plane containing Q and E. So this torque, the torque is always perpendicular to the plane containing Q and E. If we consider this as a horizontal plane, your torque will be in the upward direction, and that torque will rotate this a dipole either parallel to the electric field or anti-parallel to the electric field. So remember the torque, how torque is created in this electric dipole. So when you place a dipole, electric dipole in an external electric field, that is a uniform electric field, when you place it, then what happens? That is the net force is zero, no doubt. But since the force acting here and here are separated by a distance, so a torque is created, and that torque, so if that torque is perpendicular to the plane containing this this Q and electric field, perpendicular to it, and so because this is a electric dipole, so it will have a dipole moment P. It will have a dipole moment, so your torque is equal to dipole moment cross electric field. And if this is in a plane of the paper horizontal, then the torque will be perpendicular to the plane and it will rotate. The effect of torque is to rotate. You have learned in class 11 that the effect of torque is to rotate. It will rotate the torque either parallel to the electric field or anti-parallel to the electric field. So this is about, so do not get confused. Who creates the torque? The force creates the torque. How? Because these forces are, no doubt, they are equal and opposite, but since they are separated by a distance, so a torque is created, and that torque will rotate, and the direction of the torque will be perpendicular to the plane containing E and Q. That means if it is horizontal, if this is horizontal, your torque will be perpendicular upward, and because the torque will be perpendicular upward, it will, you know that what is the effect of torque, it will try to rotate, it will try to rotate the dipole either parallel to the electric field or anti-parallel to the electric field.